Now I will show the schematic for circuit 1. If any input we want, the output will be 1. If both input is 1, the output also will be 1. Now A is 1, the output will be 1. If B is 1, the output also will be 1. If both is 1, the output also will be 1. Now I will show the schematic for circuit 2. Any input we want will light up LED, but not both.
Step 1. So as you can see here, this is our circuit and it's working well. And now to the oscilloscope, we are supposed to measure the delay, which is TPLH. And as you can see, we can calculate from the midpoint of the first wave to the midpoint of the second wave. And the delay is written here, which is actually 32 nanoseconds. And let's go to the other side, which is TPHL from high to low. So the delay is supposed to be the same, and as you can see here, from midpoint to midpoint, it's about the same. So yeah, it's accepted, and it's a slightly different from our assumption because according to the data sheet, the delay is about 9 to 18 nanoseconds for one NAND gate, and for 4 we decided that maybe it's around 9 times 4, which is 36 nanoseconds. So there's just a slight difference in the values. Okay, now as you can see, the VOH, which is voltage high, which is written as VPP here, is about the same as our assumption of 3.3 volts. It's 3.32 volts actually, so it's basically the same. And as for our VOL, which is Vmin, it's 80 millivolts, which is very, very close to 0 volts. So yeah, I think that this part is quite a success. Hi, okay, it's me again, and there's something I have to clarify. And as you can see in this diagram, there's VOL here and VOH. How we got VOL? VOL is actually the maximum output voltage that will return a signal of 0, and for VOH it's the minimum output voltage that will result in a signal of 1. So it depending on these values, the device would get different signals. So for our VOH, we use VPP instead of VPeak because VPeak will give us a value about 3.4, which is not really consistent because it can represent an instantaneous spike, and that's why we decided to use VP peak to peak, and which is more stable around 3.3. And for VOL we use Vmin because there isn't any other value we can take, and this value is really close to 0. It's 80 millivolts, which is around 0.1 volts. So that's all for this part.
This is our calculation. We assuming that VOL is equal to 0.15, assuming according to the data sheet. Then our final answer resistor is 150 ohm, is nearly round to 120 ohms. Now we are testing our answer is correct or not. Now we can see our resistor is 120 ohm. The bulb will light up, so our answer is correct.
Hello, this is part 4 of our lab 1, and as you can see here, for part 4 we're supposed to design a majority detector that returns a value of 1 when 2 or more of the inputs is 1. So this is the brief sketch of what we came up with, and to prove if this is correct or not, we constructed the circuit. As you can see here, we have constructed the circuit, and it consists of one IC that uses two input NAND gate, and this is a 3 input NAND gate. So as you see, if I press one of the switches, I turn one of the switches on, the light here doesn't light up. But if I press 2, the light here lights up, and 3, it will still remain the same. And if I let go and I press these 2, it will still light up. If I press 1, it won't light up. If I press 2, it will light up. Or 3. Okay. So that's all for my part. Thank you.